Welcome to Podcast as Code, a show about the operations side of the software development lifecycle. I'm Mitchell Scott.
And I'm Gabe Cook.
Today, we're going to talk about how we secured a multi-tenant Kubernetes cluster while keeping our developers empowered to do the things they need to do. But first, some current events.
This one, there's quite a lot. I have a feeling we're going to talk about current events for a bit. So first of all, there was a Redis license change a couple weeks ago. It went from open source to the BSL, right? Was that one a BSL shift?
No, Redis was to server-side public license, SSPL.
Oh, sorry. SSPL, yeah. I have trouble keeping all the licenses
Yeah,
straight.
well, we'll talk about it. There's been a lot of this lately, and it's hard to keep them all straight.
Yeah. Yeah, the Redis shift kind of came out of nowhere, and honestly, I felt pretty blindsided by it. I know that Redis has a lot of features, like it's a key value store, it's a queue, it's a pub sub, it has some concept of high availability, even if, in my opinion, it's not as versatile as I'd like. But essentially, most people just use it as a key value store and like a memory cache. And it seems like a weird thing to close source. I know that they have a product and they, obviously need to make money off of it, but it really caught me off guard. I'm going to be completely honest.
Yeah, it's kind of the next chapter of open source project doesn't like that Amazon's making a bunch of money off of their software. Which on the one hand, sure, I get it. That sucks. But on the other, I don't know what these companies think they're going to gain by doing this. So we can list off the others. It's kind of started, I think MongoDB was the first one. They went to SSPL.
Yeah, that one was...
I don't remember the year. I didn't write it down.
It was years ago. And I have a feeling that is part of why, in 2015, you constantly heard about Mongo. It was a buzzword, no SQL, no SQL, no SQL. And now almost nobody talks about it. It's kind of, from what I've seen, kind of just the projects that used it. I don't think they're gaining tons of new customers. Everyone that wants NoSQL now just uses Postgres with JSON P columns.
Yeah, so MongoDB did that. And then kind of the next one in the news was Elastic. They moved some of the Elk stack behind, also SSPL.
Mm-hmm. Because
Amazon was selling Elk stack solutions for dollars that Elastic, the company, wasn't getting. More recently, actually, I think MariaDB, they went behind the BSL for MaxScale, which is a project and product I'm not super familiar with. So MariaDB proper is, as far as I know, still open source. It's not behind the business source license. But the big ones lately for the business source license have been HashiCorp. They moved, I think, all of their projects behind the business source license, behind BSL.
Yeah, that one was a big blow to open source.
And then CockroachDB is also BSL, which we haven't really used. I think we were going to look at it at one point, and then we never did, and now it's not open source.
Now we don't have to.
Why bother? And then you mentioned Sentry earlier when we were talking earlier today, and I wasn't aware of their license history. Do you want to go through that real quick?
Yeah, well, that one I like Sentry. It could be a lot if you want to try to host it yourself, but it's a really powerful service. And this one, I think they iterated on the original license change. And at this point, the general public opinion is pretty positive.
Yeah, so I think Sentry went from BSD to BSL. They found the BSL to be too complex and restrictive for what they wanted to do. So they made their own.
Yeah, they made... so this was They have a blog post about it. It's a really good post, lays it all out. I think one of the better blog posts about licenses, which are very complicated and overwhelming in my opinion.
Yeah, same.
But it says Sentry started in 2008 as an unlicensed 71-line Django plugin. Then the next year we started publishing under BSD 3. 10 years later, they switched to BSL. So I guess 2019. And then it says today. So this post was November 2023. They switched to a license they created called the functional source license. And that one's a more opinionated, simplified version of the BSL. It lowers the time that the code actually goes open source, from 4 years, which I'm going to be honest, I didn't really know existed.
I didn't either. I didn't either. But that is a long enough time to almost be useless, and which is what Sentry says in their post. And so HashiCorp bundles a new Terraform feature this year. You can use it in 2028. Fantastic.
Yeah, it's a long time. So that they lowered it from 4 years to 2. And then they also talk about how they, simplified other parts of the license, got rid of all the stringent wording and things like that. So 2 years is still a long time, but I think the general opinion of that has been, well, Sentry's already a fully featured service. A lot of the new features, are I can wait 2 years for session replays or something.
It is not a truly open source license, so they lose a point for that. But I do understand that these companies have to get paid somehow. And I don't have a better solution. So to me, that seems like a pretty reasonable compromise of, hey, we're saying that you as a competitor to us cannot have our new features for 2 years. We get 2 years of exclusivity. And then that license rolls over to, you can choose either Apache 2 or MIT.
Oh, yeah, that's another thing. The BSL is very open. Like after 4 years, it can become whatever license you want. And in their FSL, it's either Apache 2 or MIT.
Which I like both of those licenses pretty well, so that's fine for me.
Yeah, they're both pretty open licenses that still protect the people creating the code moderately well, from trademark use and things at least. Yeah. But
Sentry also has the benefit of it's not Elastic or Redis, right? It's not underpinning a million different apps that other people have built.
A majority of the internet. Well, for Sentry, I also felt like that felt like a lot of good faith from them. Like they introduced the BSL, and granted, they did wait 5 years, or I guess 4 years. Sorry, from 19 to 23.
23
but still, they decided that was a little too restrictive, and they're going to make changes and kind of play it by ear. Versus, I've never heard anyone at Mongo or HashiCorp hasn't been very, very long in the running, but it seems like the general public opinion now is like HashiCorp, made a big change that is a big deal, and it's just silence from the company. We don't hear much back. And so, I don't know, it felt like more good faith that Sentry was willing to work with people and figure out a license that made everyone happy, at least.
Yep. Well, and that's the thing with these licensing changes is, okay, why are we implementing the server-side public license or the BSL? I mean, basically Amazon, right? Like that's who they're targeting. Yeah. Is the major hyperscaling cloud platforms.
Yeah. Or, I mean, there are, other competitors, like if it's open source and it's written in a impartial way, like anyone could spin up a company and host the service. Right.
But I guess my point is you change the license, but that can't be retroactive. So like you tell Amazon, hey, you can't use Elastic anymore, or you can't use Redis anymore. You can't sell it as a service. What do these companies think Amazon's going to do? Pay them? License Redis from them?
No.
They're going to fork it.
They've got tons of engineers.
Tons of resources, and more importantly, like dollars. Yeah. Of course it's going to get forked. Sentry maybe less so, because it's kind of I guess it could, but it's more niche to me. Like it's a whole SaaS for like observability and stuff. So it's a little different than Redis, which is like a Lego block you plug into something you're building.
Yeah, although the observability of Sentry is much better than CloudWatch, but
CloudWatch is horrible. Go on. Yeah. I guess maybe Sentry's a little closer to Terraform, which is like this tool that you don't really build other things off of. You use it to do a thing. But even still, Terraform got forked. I don't know what these companies think the end game is when they do these licensing changes. Like they're not going to absorb all those dollars. The only thing that I could see is, and I really hope that Terraform doesn't go this way, but I guess this is a pessimistic view. Maybe even, I don't know. I'm usually pretty optimistic, but all these licensing changes bring me down. But if you make it BSL and like Amazon forks it, then you can implement some sort of breaking change on your end, and they have to keep up with it, I guess. Yeah, that's
and like gamble. For something like Terraform, again, I really hope this isn't the case, but they maintain a lot of plugins. Like Terraform, HashiCorp, they maintain, tons of those. I don't know who exactly maintains all the AWS and Google Cloud plugins, but in part it's HashiCorp.
Yeah.
So if they make breaking changes to Terraform and the plugins, then someone also has to fork the plugins and make sure the state files don't break between Terraform and OpenTofu or something. I mean, that would be a pretty evil outcome, and it would fragment the community even more. But I feel like that's the only way out I see, where you don't just get forked.
Yeah, it's a risk on HashiCorp's side if they choose to do something like the nuclear option of make a big breaking change. Like, do people follow you, or if people had enough of you and decide that they're not playing your game anymore, and then you're left with nothing? Because the only thing Terraform has going for it now is inertia. If you break the inertia, then you're kind of screwed.
No, the inertia and all of the business contracts I'm sure you build over years of.
Yeah, and I'm not familiar with how their business side operates. Like, I don't have any details into that. They may be self-sustaining with their existing contracts and stuff like that, with their like support agreements and whoever they're working with. They probably work with huge companies that they're either building custom features for. You have a big enough agreement, you get influence to the roadmap, which that'd be super valuable for some people, I imagine.
Yeah, I just know that they push Terraform Enterprise, so I'm sure there's some level of number of contracts they have. But
yeah, and later we'll talk about how we built our own cheap version of Terraform Cloud that's basically just GitHub Actions.
That's pretty cool to deal with, actually.
But circling back to Redis, obviously some forks have occurred.
Yeah.
You want to talk about the forks?
True. So the one that I know more about, I saw this fork, and it's actually not even like a reaction to this license change. It's been maintained for 4 years or so now. I think it was first forked also around 2019. It's called KeyDB, which for some reason I didn't expect, but it's Snapchat maintains it. But
I saw that.
It's random. It might be a good thing though, because it's not at all their core product. So I don't see them closed sourcing that at all.
Right. Yeah. It reminded me kind of about like Facebook like built and maintains an out of memory killer that I think maybe Fedora uses now. And I can't remember exactly, but there was some like out of memory killing tool that Facebook had built for their servers, and they open sourced it, and it's by all accounts a pretty decent tool, and it's not like the Facebook web app, so it's going to be like it's anyone can use it. It's fine.
That's funny. I feel like it's the small world of open source. Like, you find a cool project and it's like, wait, I know that company. But KeyDB seems really cool. That's the first one I saw, and I was able to pretty easily migrate all my personal hosting to it. It turns out it's a lot faster than Redis, like a lot faster. I found some benchmarks from 2 years ago, so possibly even better now. And it was a little over twice as fast as Redis, just because apparently the original reason it was forked was there was some people wanted to make it multi-threaded, and the Redis maintainers did not want that. And so KeyDB was born, and the multi-threading makes it way faster. So seems really cool, and so far it has worked fine for me.
Yeah, and I think you played with their high availability stuff too, right? It seemed like it was easier than, what was Redis's Sentinel?
Yeah, Sentinel. It's still called KeyDB Sentinel, but I think they've simplified. They also have multi-master high availability too, which Redis doesn't really.
Yeah.
So I would need to play with it more, but it looks more configurable than Redis, to be honest.
Nice. Well, you mentioned it's a small world in these open source projects, and I noticed that the other fork, the fork that just happened in reaction to Redis's licensing change, is called Valkey. Like, key value, but the other way around.
Oh, fun.
And that one is backed by the Linux Foundation. It's backed by a few groups, including, interestingly, Snapchat, who built KeyDB. So I'm curious to see if some of their improvements make it over, or if those projects kind of merge, or like what happens there. I don't know what's going to happen, because it's really early days for Valkey.
Yeah, that's unexpected.
But I did think it was interesting that Snapchat is involved in both of them. So whatever they're doing server side must use a lot of caching.
Yeah. News break. Snapchat uses Redis a lot.
Yeah, it must be super important, because they're now involved in 2 different projects to implement like a key value store.
Lots of Redis.
All right, let's move on to our next current event. On March 29th, the XZ, I guess it's a backdoor. It's not really a vulnerability, right? Like it's a backdoor a backdoor was introduced into a project called XZ, which I wasn't super familiar with before this happened. Did you know about that project before?
Yeah, I mean, it's one of the common, you've probably downloaded like tar.xz files. It's like tar.gz, tar.bz for bzip2. XZ is another one of these. A lot of open source projects use it, especially for things that need to be, it compresses pretty highly, XZ. So a lot of projects release using XZ like tarballs. It's not great. It luckily wasn't released, this backdoor, on any like stable channels yet. It was found very quickly. So the only people who have it are really people who run like bleeding edge operating systems, and ran an update between like the 26th through the 28th or 29th till it was reported and rolled back everywhere. But the issue, I fear, could have gotten through to production, like stable channels, pretty easily. The way it was discovered is an engineer at Microsoft noticed that SSH was going like a few hundred milliseconds slower than they expected it to. And they tried SSHing into localhost, which should be really instant. And they saw the same behavior. And they were on a bleeding edge build because it was a development build of probably the WSL, Windows Subsystem for Linux. And so they just started like sending out to some email threads like, hey, I noticed that SSH is slower than I expect. Does anyone know what's up with that? And they pretty quickly realized that there's a backdoor.
Yeah, that's important to note that, yeah, it wasn't a system in place didn't catch this like some nerd caught it. Professional nerd.
No, and yeah, some professional nerd at Microsoft. Thank you so much for
right, but it wasn't like a code review process or any testing or anything like that. It was like a human saw something weird and dug into it and found this like quickly, which I'm glad for.
Yeah.
You mentioned SSH. Let's step back a little bit. How is
True.
How is XZ used by OpenSSH?
So it's pretty highly complex, and there's this crazy graph that we can put in the show notes. But SSH in most distros loads dynamic libraries for like systemd, notifyd, and also like that's how it will call PAM things. And then systemd loads dynamic libraries for different compression algorithms, and XZ is one of them. So basically, you don't have control here. If you have OpenSSH installed and you have the vulnerable version of XZ installed, the backdoor is on your machine. So it's pretty scary. OpenSSH has since said they're going to do some changes to how dynamic loading works, which is great. But it just sucks because since this was a compression algorithm, the vulnerable payloads were hidden in XZ files, like tar.xz files in the release tarballs. They weren't committed to the repo. They were only in the release source code.
Oh, interesting.
And nobody thought to investigate them, I guess, because they're just test data. It's a compression algorithm. Of course, there's going to be zipped files where usually if you see that in a repo, it's to at least investigate. But in this case, I understand why no one caught it.
And this is a supply chain attack, right? So these files were not committed by someone brand new to the project. This individual had been working on the project for like a year and a half, right?
Yeah, about 2 years.
Okay, yeah. So this individual had likely built up a little bit of trust within the community. Like, it's not a new name. It's not unusual to see this person with commits to the project.
Yes.
I mean, we don't know their motivations yet. We don't really know a lot about why they did what they did, or whether it was state sponsored or just a single bad actor or what. Yeah. That hasn't come out yet, so we'll stay tuned to that and update you guys as we hear more about it.
As things come out.
But as far as we know now, is a single individual that over the course of a couple of years kind of laid the groundwork for this pretty sophisticated, like multi-layer compromise, this backdoor. Because like you said, Gabe, like they they put a backdoor in something that's 2 layers removed from the thing they wanted, which is ostensibly SSH keys, right?
Mm-hmm. Yeah, and these files basically they just look like test data. They're in with a bunch of other test .exe files, but when you unzip them, they unzip to bash scripts, which then modify some local code to hook into SSH and allow for a certain public key certificate to authenticate.
Oh, okay. So they're allowing a malicious actor's certificate to authenticate. It's not exfiltrating key data. It's okay. Interesting.
That's what it looks like. The investigations are still ongoing, but it's been looking like I've been following a lot of discussions and things, blog posts, and it looks like it allows a specific SSH key to get in.
Spooky. So
not great.
Here's your PSA that if you have SSH publicly exposed to all addresses on the internet, stop that. If you can, like, allow lists are your friend. VPNs are your friend.
Also, upgrade or downgrade XZ. Most distros have, even in the bleeding edge versions, the vulnerable versions were 1.6.1 and 1.6.2. And I think most of the distros have now released a 1.6.2-2, which is compiled from scratch by trusted, maintainers of the distros, and they're not vulnerable. So if you upgrade to that one or downgrade to probably like 1.4.6, you'll be covered. But still, yeah, ideally SSH shouldn't be public because it tries to SSH into the entirety of IPv4s.
It's kind of another peril of open source, right? Like everyone can contribute, but you also have things that were built organically over decades, and stuff can creep in. And this in this case wasn't even a bug. Like it was malice, most likely, like as far as we know. But like bugs can creep in too, because this has to solve a lot of cases. Like OpenSSH has been around a really long time, so it's grown over time. It wasn't 20 years ago. No one sat down and drew like a feature list of everything they wanted to build and then built it and shipped it. Right? We build a piece of it. The world changes a little bit. The SSH protocol advances a little bit. We kind of bolt that on.
Mm-hmm.
So it leaves these gaps where bad actors can put stuff in there, and unfortunately the community doesn't always catch it.
Yeah, although I want to be clear, in this case, this was not an OpenSSH problem at all.
Correct. Yeah. But you see what I'm saying, though, is like OpenSSH made a decision a long time ago to rely on these systemd components that rely on a compression library, right?
That wasn't OpenSSH. So that's why they're saying they're going to add official support for this. It was sort of a hack that the distro maintainers would put into place to get it to work better with, this specific distribution. So now SSH is saying we'll officially support this with safeguards.
So it's more complex than I thought. So it's not just the OpenSSH project, but it is open source, like the open source ecosystem of we need to solve a problem. Here's how we're solving it. I don't think anyone would call the solution that existed ideal, though.
No.
Like it worked for a long time until some clever person figured out a way to shim into a little piece of it. And I assume the folks who are running the XZ project never thought that SSH like key insertion would be a thing they had to worry about.
Mm-hmm. Yeah, so it was it's just one person that created XZ, and this was a pretty frustrating story, honestly. They maintained it by themselves for years and years, and they finally decided to put their faith in someone else, and this is what happened.
Yeah, I mean, I think you mentioned earlier that like there was some potential burnout there. So an individual comes up and says, "Hey, I'd love to help you out. Like, take a break if you need. I'll help with the project." This person then helps with the project for upwards of 1 or 2 years.
Yeah, you trust them at that point. Like 2 years,
like I would. You can't solve
probably
that
call
social
someone my
component.
friend.
Right? Yeah. I mean, like we haven't worked together much longer than that, right?
Yeah. What if I found out that you were doing malicious things? That would not be great.
I'm in your server right now. You don't.
I would be so confused. No. But yeah, so it was rough. I mean, I feel really bad for the original maintainer because they even said they posted on, I don't remember which profile, but they posted somewhere online saying like, I've seen this, maybe a mailing list. I'm on vacation right now. I've seen this. Let me get on and do a blog post tonight. And they threw together some details on the official XZ site they have. And it's like, man, they should be able to take a vacation. And here they are having to work on a project that they want to take a break from. So
yeah, it goes back to that one XKCD comic of, the one tiny block that's holding up like all of modern society. And like, this is one of those.
Yeah.
Clearly.
I think there's a lot more blocks than we even realize.
Oh yeah. Yeah. Cause every time something comes out like this, it's like, oh yeah, here, yet another like one person project that's holding up like most of the internet. It's fine.
Yep. Terrifying. But yeah, right. Let's go on to our main topic.
All right. So we covered some of the things that we're about to talk about in episode 8, Batten Down the Hatches. And I think in that episode we mentioned RBAC, Role-Based Access Control. And I think we mentioned there were some things we wanted to try, but we hadn't got around to doing yet. And now we have.
And now we've done it. And it's been working really well for a couple months now, actually. So we have a multi-tenant Kubernetes cluster that we, host many different sites in. And this sort of thing, kind of grows over time. We have us and other DevOps engineers, SysOps and TechOps. And then we have developers. We have lead developers and senior developers and juniors. And some of them know how to use Kubernetes, and they would like to be able to, make some environment variable change without needing to rely on us. And we definitely want to empower them.
Yeah, or run a quick command in a development environment. Like we use a lot of PHP, so a lot of PHP artisan commands to
kick off a job. Yeah,
you're right. Run a migration, clear out a dev database, stuff like that. Take a dump of a dev database to troubleshoot some problem on their local machine. It comes up a lot. And
yeah,
when I started at our company, all those requests were coming through DevOps because no one was comfortable in Kubernetes yet. And over the last 3 years, we've had a lot of success in empowering the devs to do more and more things, which is awesome because it means, A, we're not getting like trivial requests to do things, which is nice, right? B, the devs aren't waiting on us. Like we're not a bottleneck for them, the DevOps team, which is great. It means the devs, if someone's working late and they need a database dump from a development environment, they don't have to wait on us. They can do that themselves. Like they don't have to wait till the next day. They can finish what they're doing and call it a night. The downside though is without any of these sort of controls in place, that is scary because it means a junior dev is a few, Google searches or ChatGPT prompts away from figuring out how to do some nasty things with like kubectl.
Yeah.
And you built a tool for us called kubedb, and you even built some really basic protections into there.
Client side.
Yeah, unless you had a super secret environment variable set on your machine, it wouldn't let you touch a production namespace. But like that's a pretty thin layer of protection, right? Like kind of security through obscurity type thing.
Yeah, not good. It just prevents accidents. It's not actual security.
Right. Yeah, definitely doesn't prevent anything malicious. So you and I had talked for a long time about wanting to implement something like this. And we finally, early this year, the DevOps team sat down and kind of mapped out what all we wanted to do and tried to figure out a way to get there. So let's talk about some of our goals.
Yeah, so we obviously use namespaces pretty heavily. We have some internal apps that don't have a specific dev or prod or anything, but then, most like client sites and, external sites we host have a dev site, a prod site, possibly a stage site. So like that at the high level, we wanted most developers to have read and write. We wanted most developers to have read and write access to dev namespaces. Because overall, dev is going to have fake data. If it goes down, nobody blinks an eye. That's fine. That's the perfect environment to play around in. Senior developers then will have execute permission to most namespaces, including production, but that excludes like a lot of those internal services we mentioned. And
right, yeah, like they can't go mess around with like kubedns or anything in the cluster.
We mentioned Sentry. Yeah,
right,
Sentry. Yeah. And then there's senior DevOps engineers have everything except like namespace deletes, because we don't really need to do that. If I'm deleting a namespace, I'll use Flux and delete the manifest.
Right. Like we want a paper trail in. So we're, as we talked about back on episode 1, we're using GitOps. Our source of truth is in Git. Anything like that. Like that's not a troubleshoot. Like deleting a namespace is not a troubleshooting step. And that's all we should be able to do day to day is troubleshooting things in Kubernetes, like via kubectl. So you're right. Like deleting a namespace, that's not a cool thing for us to do without any kind of approval or paper trail, right?
Yeah. And it scared me that, everyone jokes about like rmrf / to delete your entire file system on Linux. I mean, with Kubernetes, you technically could run a similar command. Like, I'm not going to type it out anywhere, but you could pretty easily write a one-liner which gets all namespaces and then deletes all of them.
Well, and we almost had something similar happen. We had a developer who is a senior. He was playing with Flux on like a dev cluster of his own, and he didn't, but he was afraid he did a Flux bootstrap against our production cluster, which I'm not exactly sure what would have happened. I don't think any of it would have been good. His local cluster didn't behave how he thought it should when he ran that, so he was like, "Oh God, guys, did I run that against prod?"
Did I do it?
And we looked and we're like, "No, everything's fine."
But we were like, "Wait, do we need to restrict prod access?"
But again, like we have devs starting to play with Kubernetes, so they could easily be a context change away from, not even realizing where they're at. And like, I'm going to wipe, I don't need anything in kube system for whatever reason. I'm just going to delete that namespace. And then, just through accident cause some big headaches for us. So we want to make sure that is impossible. Even for us, even for ourselves and our daily driver accounts, right?
Yeah, might as well, because I'm not deleting things often. So I mentioned, you're right, no namespace deletes, but really, we don't need to delete most things.
No, probably the only things are like pods and maybe some PVCs for when we do like Postgres.
Or like ingresses if
Oh, that's true. The ingress shuffle's annoying. Yeah.
Sometimes that one's weird. But senior DevOps, so this is where it's like not as much for security, it's more for just preventing accidental outages. But we then have like a God mode role that we can assume, and that lets us do whatever we need. Sort of like a break glass.
That is super admin.
Yeah, super admin, but we don't use it from day to day.
No, for me that's a separate context. I have to change into.
Oh, mine's not even a context. Mine's just in my config file. And if I need it, I can change the user in my kube config. Yeah.
Yeah, so I have it as a second context, and I actually had to use it today.
Oh, good.
I could not describe cluster role bindings as my regular user, which I did to prep for this.
Oh, yeah, those are... So you were planning out the synopsis and you
and I was like, permission. I have to escalate.
Working as intended.
Yeah, and it's great to see. It's like, oh, you're right. That is like kind of that is a higher level of access. No one should need that. And if you or I do, like we have a way to go get the stuff we need. But it's an intention. It's like pseudo whatever, right? Like,
yeah,
you need to take an explicit action, realize you're elevating to a non-standard account, and do the thing, and then get out of it again.
Yeah, because even someone knowledgeable can make mistakes. I mean,
oh, absolutely.
A site could be down and a client could be, really wanting it back up, and we could be on time constraints, like fix it, and delete something important. So even during a panic time, it's good to try to limit what you can do.
Yeah.
And then past that, we try to avoid this, but there are certain cases where if we need to, we can grant a specific user special access. So like we, have this internal app that a certain group of developers have built, and it's internal enough that we don't mind granting them production access. We can do that. No problem. And we can easily restrict it in the future whenever they're done developing. So that's the goal. We got into some implementation stuff there, but that was the goal.
Yeah. So let's talk about how we did it. The first step is like building out the groups we needed. And there's a few different ways you can do this. And we kind of went with a really broad approach to start. And down the road, we may limit it more. And we have the power to do that at any time. So we kind of talked about the groups too in the previous bit. But the groups are basically like read almost everything, the junior developer-ish role of like read write to dev, and then the senior role, right? Those are the groups that we've kind of defined out.
Yeah. Yeah, we called them user, admin, and super admin.
Yep.
Mm-hmm.
So we use G Suite, or the product formerly known as G Suite. I don't know what they're calling it, a Google Workspace maybe.
Yeah, Google Workspace.
So we're using that for our group management because we use, we're a Google shop. We use Google email. We're talking about our cluster that's in GCP.
Apparently this feature works with Azure also. Apparently Google and Azure integrate somehow here. Like if Azure's your authentication provider and then your cluster's in
like
Google
Azure,
Cloud.
the product formerly known as Azure AD that's now something
Ooh.
else. Intra.
For us, our user management is mostly in Google Cloud, Google Workspace, and our Kubernetes clusters are mostly in GCP, like GKE clusters. And so GKE has a feature called Google Groups for RBAC. So like Mitchell mentioned, we can set up actual groups, which typically are used for like email groups in like Google Workspace account. But in this case, you can use them for permissions. So we can add users to a specific group and they'll get that permission in the cluster. And then within the cluster, we have cluster role bindings for like a read-only one and a read-write, I think. And we can grant that to the different groups.
Yeah, so, and I think we might have talked about it back in episode 8, but there are role bindings, there are roles, there are cluster roles and cluster role bindings. And the ones with cluster, that start with cluster, those are not namespace, right? They're cluster wide. The ones without cluster, like roles and role bindings, those are namespace specific. And this is kind of how the magic works with these. We actually didn't build any roles for this or cluster roles.
No.
And that's one of the last things you figured out that was kind of the key to this is instead of maintaining a really long list of permissions we wanted to grant, we can actually, everything we needed was in the defaults. Kind of the cluster roles that ship with at least GKE. I think it's all Kubernetes flavors of like view, edit, and admin. Those would be enough for us to do anything we need to do.
And they're actually even cooler than that. I didn't know these existed before a couple months ago, and I don't know how I missed them. I really wish I was aware of them. They not only are defaults, but they also are aggregated. So tools can add their own cluster roles and say, I want these rules to aggregate to like the view role or the edit role. So like Flux CD, when you install it, it'll automatically add rules for all of its manifests to the view cluster role and the edit cluster role and the admin. I saw the same for Cert Manager, and a lot of tools that create CRDs will automatically add their own rules to these. So we were nervous, like Mitchell mentioned, that we'd have to maintain this massive list of grants, and we didn't have to do that at all. I think I added like 1 or 2 permissions that we needed kind of as a special case, and that was it.
Yeah. Well, the nice thing is Kubernetes has thought this out pretty well. Like the view role doesn't have like get secret access, right?
I was surprised by that. Yeah, it lets you view pretty much everything except secrets.
Because that was the one case we were like, oh man, we definitely don't want anyone viewing like prod secrets who shouldn't. And then it was built in.
Mm-hmm.
So that was kind of the cleverest bit of this is the part we didn't even do. Like the project did all this work for us, but we realized that it was there and took advantage of it.
Once again, the clever bit is just Kubernetes.
Right. Yeah.
But go on.
So I think in the end, we ended up building 2 cluster role bindings, an admin and a view.
Yeah. We gave one so that overall anyone can view the cluster.
Yep.
And then overall admins can admin the cluster, but we didn't give anyone like write access to production. That will be what you're about to mention.
Right. So that admin cluster role, that's our cluster role.
Yeah, that's for like
we
DevOps.
assume. Right. Mm-hmm. So then like how do we give a developer who's not a senior, who doesn't know enough about Kubernetes to have the keys to the kingdom? How do we give them access to like the dev namespaces?
Yeah. So then in dev, it's not cluster level. So this is one thing where it's a little bit manual, but this manifest is like 8 to 10 lines long. So it's fine. It's pretty easy to make that just get created with each namespace. For like the dev namespaces, we'll add a role binding that grants users edit access. So people that don't have super user can edit in dev. And luckily that includes like execing into pods, things like that.
Right. And that is, when you say users, we're not mapping that to specific users. We have a group of
the users.
It's all group based, which is also what you need if you're going to try to go get SOC 2 compliant or any of those things. Like everything needs to be group based membership. Super important. And this totally conforms with that. So, as soon as we deactivate a G Suite account, that person has no access. Or if we change a membership like that, it's pretty quick to get down into the cluster. So that's how we did it. We'll post in the show notes. We'll link to Google's document about configuring Google Groups for role-based access. It was a little finicky, that part, I thought. And I think that comes from us not being super familiar with it. When we set out on this journey, we didn't even know what exactly was possible.
Yeah, I felt like it came a little bit from also like, at least personally, I think you're in the same boat. We had a pretty high level knowledge of Kubernetes as a whole, but I had never really, I'd only slightly messed with like role bindings and all of the RBAC stuff.
Well, and we use a lot of Helm charts. So even our apps or the solutions we deploy that use RBAC, the maintainer of the chart already figured it out. Like we're not handcrafting a bunch of RBAC manifests generally.
Yeah. Yeah, that's true.
So that was kind of a new thing for us to figure out exactly how we wanted it to work.
Well, and I think the big surprise was like Google's doc makes it just look magic. It's like, yeah, all you do is turn this on, add your groups, and now you're good. Like you just now grant the groups access. And you and I were like, no, that's not how there's no way. That's too easy. And then that was how it worked.
Yeah, we definitely went through the 5 stages of AWS is easier and better at this to actually Google's better. Actually, wait, is AWS easier? I at least understand what's happening there. There's less magic. And then Google, once it worked, was like, oh, this is actually really cool.
Oh, this is actually really good. Yeah.
Yeah, I think we were thinking we would have to build out the service, the Kubernetes service accounts for these groups. And you just don't. You don't have to.
Yeah.
Google Magic does it.
It just like authenticates into the cluster with that group. So it's like how you can, in an AWS cluster, you have that auth config map and you can add like email addresses or like IM, like ARNs.
Right. And even like our developers, we don't have to go into their kube configs and specify like a role assumption. That doesn't need to happen. The group memberships are just attached to them. That's one thing we had to figure out is how do we limit our own access? That was kind of a tricky part because we have like our GCP roles or our like we are super admins. So for us, we do have to assume that role. Yeah.
As a super admin, you can assume other roles, luckily. So
right. So like we assume that just normal admin role. But that's okay, because our DevOps folks can edit a kube config. We don't want our developers. Like, we even started to talk about, okay, we need to build a tool to help to generate kube configs that have all the things. And then you just don't have to. We were way overthinking it. It was simpler than we thought. And in the end, it turned out to be a super elegant solution. I'm really happy with everything.
Well, and then we started to realize that these integrate into GCP a lot more than expected, too. Like, the users group, we can grant, like, log viewing access. And then we don't have to grant each person access to a project.
That's right, yeah.
If we give it log viewing access, everyone in that group can view logs all of a sudden. And it's just really elegant. I've been very impressed.
Yeah, so let's talk about the results. So devs who aren't super familiar with Kubernetes don't have to be afraid that they'll hurt production. Mm-hmm. They are free to learn and break development, which is perfectly fine. Those environments are not important, and if they happen to be, they're backed up. So outages are not a problem for development environments. The only person that's going to inconvenience is like their fellow dev team, and that's fine. Like our clients don't care. So like when I got started here, I was super nervous for the first like 3 months that I was going to just destroy some production environment. And that was before we had secrets in a place that I was comfortable with.
Yeah. Yeah, when they were just in the cluster instead of like GitOps.
Right. Yeah. So like if I had deleted a namespace 3 years ago, it would have been a rough day to get all that stuff back. We could have done it, but it would have.
We had them like in password managers, but it would have been.
Yeah, but it wouldn't have been quick. Now,
day.
if a dev wipes out like the dev, I mean, they can't delete the namespace, but if they wipe out like the pods or the deployments, like A, client doesn't care about an outage. B, Flux is going to reconcile it almost instantly anyway. Yep. Like it's almost self-healing. So it gives our devs a little breathing room to not be uncomfortable trying to learn new things that are like hard for them, because like they literally can't hurt anything. Like there's no way they could run whatever horrible command the internet tells them to run, and they cannot hurt a production environment, which is awesome.
Which is amazing. Nor an internal app, like an internal production app.
Right. Yeah. And another result is that like you and I, Gabe, we spend less time troubleshooting human errors against production, because we don't have like there's just no, I accidentally restored the dev database to production instead of dev, which has happened. Which is kind of that's a panic event of like, okay, well, we have backups of production. We'll go restore one. Site has to go down for a couple minutes to do that. And now our day is ruined, or like at least like
now I'm grumpy.
Lunch is ruined. Yeah,
that's true.
Also, better compliance. Like we talked about, a lot of these frameworks, SOC 2, NIST, ISO 27001 or whatever, they require A, like group membership for access, and B, also like principle of least privilege is super important. I think we talked about it back in our Securing Kubernetes episode, but like if someone doesn't need exec access to prod, they should not have it. And obscurity is not good enough. Or like the other result is we don't have to solve this with like our custom tooling we build. Kubernetes has solved it. We can rely on Kubernetes to enforce it.
Yeah. And I mean, at the same time, better compliance, but also it has allowed us to even grant people access in the first place. I mean, I know that started happening, but I felt like I was always tiptoeing a very fine line here, because really one of the goals of DevOps is like empowerment, like make devs' lives easier. So I hated saying like, no, you can't. But I'm always I lean on the side of give as little access as possible. And apparently I started like frustrating devs because I was really trying to keep everyone out of the cluster except DevOps. So it's really nice now that I can just say, no, that's fine. I can add you, no biggie, without being kept up at night.
That's kind of why the senior devs are a special category, is like, A, they need access to production in some cases. But we had already given, like, our senior devs were some of the few people who weren't on the DevOps team that had cluster access at all. So it used to be like, okay, you need to be pretty senior. You need to know what Kubernetes is. You need to show us that you're trustworthy to have any access to Kubernetes. And now, since everything's role-based and like devs in general can't break production, have access. Go crazy. Yeah. It's fine. Like, this is great.
It's the ideal, like, implementation, I feel like, for DevOps.
Yeah, it's really good. It gives it, like, we're spending more of our time doing the things that I think we should be doing and less time doing things that the devs could be doing, which means the devs are going to learn Kubernetes. They're going to get more valuable skills in their tool belt. And also, they're not waiting on us. Like, if I go to lunch and you're out sick, devs can still get their work done.
Yeah.
Like, we definitely do have clients that we work with, but fundamentally, the developers at the company we work for are our biggest client. They're our customer. They consume the services we build. And our job is to make that as easy for them as possible. Mm-hmm. And with this solution, I mean, we've done it. This is the way it should have been all along. So if there's anybody out there who hasn't figured out this role-based access stuff yet and thinks it's really difficult, it's a little tricky. You have to get down in the weeds just a little bit. Spend a couple days on it. And I think you'll have it, because that's about how long it took us.
Yeah, and then you'll look back and be so happy you did.
All right, I think that about wraps it up. Thanks for listening. Our website is podcastascode.show. If you would like to suggest topics for us to cover or have feedback on topics we have covered, send us an email. Our address is contact@podcastascode.show, or you can hit us up on Discord. Join us in a fortnight for more DevOps content.
See you next time.